Hello, this is novaTopFlex. In this video, I will be speaking about customizing the Debian GNU/Linux system. So first, how to ensure that all systems use the same paper size. Install the libpaper1 package and it'll ask for a system-wide default paper size /etc/paper size. Users can override this paper size setting using the paper size environment variable. See the man5 paper size manual page. To provide access to hardware peripherals without compromising security, many device files in the /dev directory belong to some predefined groups. For example, /dev/sr0 belongs to the CD-ROM group. For a certain user to have access to one of these devices, just add the user to the group the device belongs to. For instance, add user, user, group. This way, one will not have to change the file permissions on the device. Doing this from within a user's shell or a graphical user interface environment, one would have to log out and log in again to become an effective user of that group. To check which groups you belong to, run groups. Notice that since the introduction of UDEV, if one changes the permissions of a hardware peripheral, they might be adjusted for some devices when the system starts. If this happens to the hardware peripherals, we'll have to adjust the rules at etc UDEV. To load a console font on startup the Debian way, the KBD package supports this. Edit the etc kbd config file. To configure an X11 program's application defaults, the X programs will install their application resource data on the /etc/x11/app defaults directory, app defaults. To customize X applications globally, put customizations in those files. Marked as configuration files, so contents will be preserved during upgrades. How does a Debian system boot? Like all Unix-like systems, Debian boots up by executing the program init. Like most Linux distributions, the default Debian system uses systemd as the implementation of init. Traditional System 5 style init and other methods are also supported. To control the order in which services are started, traditional System 5 style Unix systems use run levels. These are replaced by targets under systemd. To display the default target to which systemd will bring the system, run systemctl get default. During boot up, systemd starts the services or other targets listed in the default target file /lib/systemd/system/default.target. The files for these services and targets are installed and the service is enabled during Debian package installation. If you specifically wish not to start a service during boot up, instead of removing the corresponding package, you can run systemctl disable and then servicename.service using the name of the service file installed in /lib/systemd/system, usually based on the name of the package. The service file /lib/systemd/system/rc-local.service provides an easy way to run customized scripts in the file /etc/rc.local after boot up. Similar to what's offered on Debian systems running System 5 style init. Beware that this script will fail if it tries to interact with the console, such as asking for a user password or trying to clear the screen. You can check the status of any service by the command service and then whatever package status. To start or stop a package service, it's the package name service, package start, and service package stop. This service command works with any init supported on a Debian system, not just systemd. If you, however, prefer to use the same command on any systemd-supported Linux system for checking the status, run systemctl status and then package name, or whatever the package name is, .service to get the same information. For more information on systemd for Debian, it's on wiki.debian.org/systemd. And how about Debian and traditional System 5 init? Debian supports booting using traditional System 5 init via the sys5init core package, sysvinit. The configuration file for System 5 init, which is etc/init tab, I almost said init lab, it's init tab, specifies that the first script to be executed should be /etc/init.d/rcs, lowercase rc, uppercase s. This script runs all of the scripts in /etc/rcs.d by forking subprocesses to perform initialization, such as to check and to mount file systems, to load modules to start the network services, to set the clock, and to perform other initialization. After completing the boot process, init executes all start scripts in a directory specified by the default run level, given by the entry for id and /etc/init tab. Like most System 5 compatible Unices, Linux has 7 run levels. 0 is halt the system, 1 is single user mode, 2 through 5 is various multi-user modes, and 6 is reboot the system. Debian systems come with ID equals 2, which indicates that the default run level will be 2 when the multi-user state is entered, and the scripts in /etc/rc2.d will be run. Debian uses dependency-based boot ordering through inserv using the LSB headers in each script under /etc/init.d, as well as parallel concurrent booting through the use of start par to speed up the boot process. Scripts in any of the directories /etc/rcn, with n being any number, .d are just symbolic links back to scripts in /etc/init.d. However, the names of the files in each of the rcnd directories are selected to indicate the way the scripts in the init.d will be run. Specifically, before entering any run level, all the scripts beginning with K are run, which kill services. Then S starts services. The 2-digit number following the K or S indicates the order in which a script is run. Lower numbered scripts are executed first, K for kill, S for start. This approach works because the scripts in etc initd all take an argument which would be either start, stop, reload, restart, or force reload, and will then do the task indicated by the argument. These scripts can be used even after a system has been booted to control various processes. For example, with the reload argument, the command /etc/initd/sendmail reload sends the sendmail daemon a signal to reread its configuration file. Note that the invoke rc.d should not be used to call the etc initd scripts because service should be used instead. And are there yet other ways of booting a Debian system? Like System 5 init but don't like the etc rc whatever d links, could install the file rc package file-rc. This will convert the links into one single configuration file etc run level conf instead. If you like neither System 5 nor System D, you might like OpenRC or Runit or daemon tools. How does this package management system deal with packages that contain configuration files for other packages? Some will wish to create, for example, a new server by installing a group of Debian packages and a locally generated package consisting of configuration files. Not generally a good idea, because dpackage will not know about those configuration files if they are in a different package, and may write conflicting configurations when one of the initial group of packages is upgraded. Instead, create a local package that modifies the configuration files of the group of Debian packages of interest. Then dpackage and the rest of the package management system will see that the files have been modified by the local sysadmin and will not try to overwrite them when those packages are upgraded. To overwrite a file installed by a package so that a different version can be used instead, do not overwrite bin login with login-local. The package management system will not know about this change. It will simply overwrite the custom bin login whenever login or any package that provides bin login is installed or updated. So login local rather than login provided. So do not overwrite. Instead, do dpackage-divert /bin/login.debian/bin/login in order to cause all future installations of the Debian login package to write to the file bin login to bin login.debian instead. Then execute cp login-local /bin/login. So dpackage-divert has which diversions are currently active on the system. Details are given in the manual page, not package, manual page. So it's man8 dpackage-divert. To have locally built packages included in the list of available packages that the package management system knows about, dpackage, scan packages, and then the binary directory bindir is a directory where Debian archive files, which usually have the .deb extension, are stored. Override files edited by the distribution maintainers and is usually stored on a Debian archive at indices/override.main.gz for the Debian packages in the main distribution. This can be ignored for local packages, and path prefix is an optional string that can be appended to the mypackages file being produced. Once that mypackages file is built, tell the package management system about it by using dpackage-merge-avail my_packages. If using apt, then the local repository can also be added to the sources.list file as well. So some users like Amok, some like QOC, some like Vim, others like Elvish, some like TRN, others like Tin. How does Debian support diversity? There are several cases where two packages provide two different versions of a program, both of which provide the same core functionality. So users might prefer one over another out of habit or because the user interface of one package is somehow more pleasing than the interface of another. Other users on the same system might make a different choice. So there's a virtual package system to let administrators choose or let users choose favorite tools when there are two or more that provide the same basic functionality yet satisfy package dependency requirements without specifying a particular package. So tin or turn, both being provided by the virtual package of newsreader. Which programs invoked is determined by a link pointing from the file, so it's in /etc/alternatives/newsreader to the selected file, like user bin turn. A single link is insufficient to support full use of an alternate program. Normally, the manual pages and possibly other supporting files must be selected as well. The Perl script update alternatives provides a way of ensuring that all the files associated with a specified package are selected as a system default. For example, to check what executables provide X window manager, run update alternatives --display X window manager. Instead of --display, run --config if you want to change it. And then follow the instructions on the screen. Basically, press a number next to the entry you'd like better. If a package doesn't register itself as a window manager for some reason, file a bug if it's an error, or use a window manager from user local, the selections on screen won't contain your preferred entry. You can update the link through command line options like update alternatives --install user bin X window manager and then X window manager and then /user/local/bin/ and this is an example with wmaker-cvs50 or 50. First argument to install is a symlink that points to /etc/alternatives/ the name is the second argument. The third is a program to which etc alternatives name should point to. The fourth is a priority. Larger value means that the alternative will more probably get picked automatically. To remove an alternative added, simply run update alternatives -- remove X window manager. This example is user local bin wmaker cvs. If you like this content, please like, share, give a comment, subscribe, hack the YouTube algorithm, and thanks for watching. See you next time.